Welcome to MRL. In this learning session, we'll be learning about similar triangles and all the aspects of similar triangles. But before we proceed with the similar triangles, let us understand as to what are congruent figures. Now, two figures are congruent if they have the same shape and the same size. And the symbol of congruency is a small wave with two parallel lines. As example, let us take a few examples here. Congruent circles. Two circles are congruent if they have the same radii. If you look at circle C1 and circle C2, they are congruent because the radii of both the circles are the same. The radii are same, therefore they are congruent. Rather, if I pick this circle C2 and place it on C1, they will coincide or superimpose. Therefore, the two circles are congruent. Now, two triangles are congruent if their corresponding sides and angles are equal. That means if triangle ABC and triangle PQR are the two triangles, then if angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R, side AB is equal to side PQ, side BC is equal to side QR, side AC is equal to side PR, then the two triangles are congruent. Or if I lift the triangle PQR and place it over ABC, they will coincide or superimpose. Therefore, the two triangles are congruent. Remember that. Now, similar figures. Now we know what are congruent figures. Now let us understand what are similar figures. Two figures are similar if they have the same shape, but the size is proportionally smaller or bigger. Now if I take example here, the two circles are similar because they have the same shape, but they are proportionally bigger. That means circle C2 is proportionally bigger than C1. They are not of the same size, but they are the two circles are proportionally smaller or proportionally bigger. Now if you take the two squares are similar as they have the same shape, but their sides are proportional. That means if I take the ratio of PQ upon AB, that is 4 upon 2 is 2. So also the side QR divided by BC, side CD divided by side SR divided by CD, and side PS divided by AD are having the same ratio 2. Now if you observe here, that is all because the square PQRS has the side measure of 4 centimeters, whereas the square ABCD has the side measure of 2 centimeters. So if I take the ratio of the corresponding sides, then we find that the ratio is the same, and therefore these two figures, that is two squares, are similar. So two squares are similar if they have the same shape and their sides are proportional, and that is true here, and therefore the two squares are similar. Now what are the conditions for polygons to be similar? Let us take a few examples and understand and conclude it. Now I have taken two polygons here. One is a square, the other one is a rectangle. In a square and a rectangle, the corresponding angles are equal. That means angle A is equal to angle P, angle B is equal to angle Q, angle D is equal to angle S, angle C is equal to angle R, all are equal to 90 degrees. But the corresponding sides are not proportional. If I take the ratio of the corresponding sides, that means they are not proportional, that is they don't have the same ratio. Therefore these two figures or polygons are not similar. So this is the symbol of non-similarity, whereas the symbol of similarity is just three vertical lines. Remember that. Now that means the conclusion is the two polygons are not similar because their corresponding sides are not proportional, although their corresponding angles are equal. Now let us take two more polygons. We have taken a square here and a rhombus. In these two figures, the corresponding sides are proportional, but the corresponding angles are not equal. Therefore, these two polygons are also not similar. So therefore, now the conclusion is, when will the two polygons be similar then? The two polygons are similar if their corresponding angles are equal and their corresponding sides are proportional. Therefore, remember the conditions for two polygons to be similar are their corresponding angles are equal and their corresponding sides are proportional. Now when we compare congruency and similarity, we find that all congruent figures are similar. All congruent figures are similar, whereas all similar figures are not congruent. Remember that. Now, before we start with the basics of similarity of triangles, let us understand some important basics here. Now, corresponding parts of triangles. If you take triangle ABC and triangle PQR, then if you take the vertices of these two triangles, the vertex A, and if I name these two triangles as triangle ABC and triangle PQR, then vertex A corresponds to vertex P, vertex B corresponds to vertex Q, and vertex C corresponds to vertex R. This is the symbol of correspondence. Now if I take the angles, then angle A corresponds to angle P, angle B corresponds to angle Q, angle C corresponds to angle R. if I take the sides AB corresponds to PQ, BC corresponds to QR, and AC corresponds to PR, and this correspondence holds only if I name the triangle as ABC and PQR. Rather, A should coincide with P, B should coincide B should correspond to Q, then only this correspondence holds. Otherwise, it does not hold. So remember, the corresponding parts of triangles is a very, very important basic as far as learning of similar triangles is concerned. Now, the proportional sides of triangles. The sides of triangles are proportional if the ratios of the corresponding sides are equal. Now, if I take triangle ABC and triangle PQR, if AB upon PQ is equal to BC upon QR is equal to AC upon PR, then the corresponding sides are proportional because they have the same ratio. If I take the ratio, all the three ratios, they have the same value, and therefore the corresponding sides are proportional here. Remember that. Now, coming to the conditions for two triangles to be similar. Now, triangles are also polygons. Conditions of similarity of polygons are also applicable to triangles. However, for triangles, even if one condition of the conditions of polygons is satisfied, then triangles are similar. That means the triangles are similar if their corresponding angles are equal or their corresponding sides are proportional. One of the conditions have to be fulfilled for the two triangles to be similar. Now, let us take the triangle ABC and triangle PQR here. In these two triangles, if angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R, then these two triangles are similar. Also, in these two triangles, if AB upon PQ is equal to BC upon QR and AC is equal to AC upon PR, then the two triangles are similar. That means either this condition is to be fulfilled, that is the corresponding angles must be equal, or the corresponding sides must be proportional for the two triangles to be similar. But there are different criteria for similarity of triangles. The different criteria for similarity of triangles are the AAA and SSS criteria, AAA criteria or AA criteria, SSS criteria, and SAS criteria. We will be learning all these criteria and also be proving these criteria in our study further. Now, coming to the next point, that is basic proportionality theorem. A very important theorem in similarity of triangles, which was given by Thale. Therefore, it is also called as Thale's theorem, or famously it is known as BPT. Now, what is this basic proportionality theorem or BPT or Thale's theorem? Now, it states that in a triangle, a line drawn parallel to one side divides the other two sides proportionally. Now, what does this statement mean to us? Now, we have a triangle ABC. DE is drawn parallel to BC, that means to one side. Then it divides the other two sides, that is AB and AC, in the same ratio. Means the D is the point of DE here. Therefore, D is dividing the side AB in the ratio AD by BD, and also divides AC in the ratio AE by CE, and these two ratios are equal, and therefore they are proportional. So, remember this. In a triangle, if a line is drawn parallel to one side, it divides the other two sides in the same ratio or proportionally. Now, let us understand and prove this. Now, we are given a triangle ABC. DE is parallel to BC. Now, as far as construction to prove this is, there are simple constructions. Join BE and join CD. Draw DF perpendicular to AE and EG perpendicular to AD. Now, the proof is also very simple. Take the triangle ADE, that is area of triangle AD. We have to take the ratio of two triangles here. Area of triangle ADE upon area of triangle BDE. That means ADE triangle and BDE triangle. I have taken here ratio. Now, area of triangle ADE is equal to half into base into height, that is half into AD into EG, divided by the area of the triangle BD will be again half into BD into the height, that is EG. That is equal to half cancels, the EG cancels, therefore it is AD by BD. Let us call this as 1. Now, let us take the triangle AED and the triangle CED. Now, let us again take the ratio of the areas here. Area of triangle AED divided by area of triangle CD is equal to half into base into height, that is half into AE into DF, that is the height of the triangle AED, and also the area of triangle CD is equal to half into CE, that is CE, and the height DF again. Half cancels, DF cancels, we get AE upon CE. That is, let us call this as 2. Now very interestingly, area the triangle ADE and AED are the same, and therefore area of triangle ADE is equal to area of triangle AED. Therefore the numerators are same in both in the LHS of 1 and 2. And also if you see the triangles BDE and CED, they are standing on the same base DE and between the same two parallel lines DE and BC, and therefore the area of those two triangles are equal. We already learned this, that the triangles standing on the same base and between the same parallels are equal in area, and therefore the denominator of the two ratios here are also equal. That means the LHS of these of 1 and 2 are equal. Therefore we can equate RHS, that is AD upon BD is equal to AE upon CE, and that is the proof of this particular theorem. So but you can do one thing: you construct a triangle ABC yourself, draw DE parallel to BC, measure the sides AD and BD, AE and CE, take the ratios and find out whether this particular theorem is true or not. Okay, verify it. Now coming to the next very important statement, and that is called as the converse of BPT. Now the Converse of BPT states that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Now what does this mean to us? Now we have been given a triangle ABC, and D is a line, and D is a line such that AD upon BD is equal to A upon C. That means the line D divides the two sides AB and AC in the same ratio, that is AD upon BD is equal to A upon CE. If that is correct, then D is parallel to BC. That is exactly what is the statement. Therefore, if a line divides any two sides of the triangle in the same ratio, then it is parallel to the third side. Now let us understand this and also prove this. Now take triangle ABC and draw D, which divides the triangle ABC in the ratio AD by BD is equal to A by CE. Now we have to prove that D is parallel to BC. Now instead of D, let DF be parallel to BC. If DF is parallel to BC, then AD upon BD is equal to AF upon CF by BPT, we have learned and we have also proved it. Now we have been given that is AD upon BD is equal to A upon C. See, by drawing DF, taking DF as parallel, we got the ratio, the two ratios by BPT, and what is given to us is AD by BD is equal to A upon C. Now you find that LHS is same, then that means I can equate the RHS. By equating the RHS, I get AF by CF is equal to AE by CE. Now adding 1 on both the sides, I get AF plus CF by CF, AE plus CE by CE. But what is AF plus CF? AF plus CF is AC, so I have that is AC, and AE plus CE is also AC. Therefore, it is AC by CF is equal to AC by CE. Now taking the reciprocal of these two, I get CF by AC is equal to CE by AC. AC gets cancelled, then CF is equal to CE. That means CF is equal to CE is what we have proved. If CF is equal to CE, it means F must coincide with E, or D is the only line which can be parallel to BC and not DF. Therefore remember, D is parallel to BC here. That is what is the proof of the converse of BPT. Remember that. Now coming to the corollary of BPT, and this is the very, very important basics in similarity of triangles. Try to understand this. If a line is drawn parallel to a side of a triangle, a new triangle is formed. See, if you take a triangle ABC, you draw a line DE parallel to BC, the new triangle AD is formed. The corresponding angles of the intercepted triangle, and this triangle which is formed AD is called the intercepted triangle. The angles of the intercepted triangle ADE and the given triangle ABC are correspondingly equal, and it is true also. If you see, angle A is common to both the triangles ADE and ABC. D is parallel to BC, therefore angle B and angle D are equal because they are corresponding angles. So also angle C and angle E are equal because they are corresponding angles, and therefore the three angles of triangle ADE and triangle ABC are equal. Therefore the triangle ADE is similar to triangle ABC. That is what you have to remember, because we know that the condition for two triangles to be similar are the corresponding angles must be equal. Here the corresponding angles are equal, therefore triangle ADE and triangle ABC are similar triangles. But also we know that if two triangles are similar, then their corresponding sides are proportional, and therefore AB upon AD is equal to BC upon DE is equal to AC upon AE. So this is what is the corollary of BPT. Please remember this. So the corollary of BPT is a very, very important basic for us to remember, and very useful in solving examples related to similarity of triangles. Please remember this. Then we'll further in the next session we'll proceed with the what you call proving the different criteria of similarity of triangles. Okay, thank you.